Hey what's up guys, my name is the Cherno. Welcome back to another code review. Yeah, this series is still alive. So basically, for those of you who have not heard of this series, I'll have like the last episode linked up there. There's like a whole playlist and everything. This is basically just me taking a look at the code that I received from the community, from you guys. And this can be absolutely anything. In fact, I've been thinking about this series, and I think that rather than me trying to critically, judge your code as if I'm like, somehow authorized to do that or whatever. I'm not your academic professor, right? This would be more of like a little fun series, fun, trying to inspire fun in my life and in yours as well. Where basically I would just look at interesting code from the community, give my thoughts, I might give some suggestions, I might just, speak my mind, but it is not supposed to be like a, hand in your homework and Cherno will mark you and then probably discourage you from ever programming again, which can be the case. So yeah, so that's kind of long story short of what this series is. Today we have Alexander Volnov. I don't know. Hi, my name is Alexander, I'm 26. Good start. I'm also 26. Привет из России. Also an excellent start. First of all, thank you for your content, and particularly the Game Engine series. I used to develop my 3D game engine for a long time as a hobby, but abandoned it 5 years ago. That's understandable. Game engines are very difficult to make. But recently I discovered your channel and your videos gave me some new ideas and inspired me to continue development. Cool. Wanted to share a demo that implements a simple particle rendering technique in C++ and OpenGL. I came up with it while I was developing my engine and later extracted it into a separate demo. The demo also has some music and it fits in just a single 4K executable. Cool, so it's like literally like a demo scene style demo. That's really cool because I have not looked at anything close to this, and that's actually one of the reasons why I selected this. Here is the link to the repository. All right, let's take a look at these particles. I haven't taken a look at this really. I've skimmed through it to make sure that it's going to be decent content for you guys, but I haven't really examined it yet. So this is what it looks like, I guess. It's a demo. GPU particle system technique written in C++ and OpenGL 3. Also simple procedural music inside. Cool, so I guess the music gets created by the actual software. There's a pre-built 4K binary. I might open that. Before you do so, see control section below, blah, blah, blah. So it's CMake, demo, blah, blah, it's a demo. Oh, and good, some interesting controls. So I might save these controls. How it works, that's cool, seeing a little how it works section, so I don't have to explain that to you guys, I guess. And like most existing methods, my technique doesn't do any step-by-step simulation. Instead, particle trajectory, size, color, and other parameters are defined as functions of time. Yeah, so that's pretty common to see like on Shader Toy. For those of you who don't know, by the way, that's probably a good kind of thing. If you guys are interested in stuff like this, if the stuff that I'm about to show today interests you, you should definitely take a look at Shader Toy. Shader Toy is a website, it sounds like they're sponsoring this video. Shader Toy is a website that basically just has people writing various shaders that do things, and because there's no real state, like you can write to textures and do stuff like that, but there's no real state, like this isn't like an application or a program, it's kind of all generated using this kind of shader text, and essentially it's a fragment shader running like on a quad. So because of that, a lot of it is like a function of time or a function of like the mouse, location, stuff like that. So this is cool. It's kind of similar, and I always love looking at this stuff, to be honest. Speaking of sponsors though, however, this video is sponsored by Skillshare. So for those of you who don't know, Skillshare is an amazing online learning community where millions of creative and curious people from all around the world can come together into one place to learn some new skills through their amazing selection of high quality classes. Whether you're trying to learn a new skill or polish up an existing skill, Skillshare is the perfect place for you. They have classes on literally everything. If you're interested in photography, videography, marketing, video editing, in fact, there's a fantastic course that I've just been watching today by MKBHD that just teaches you all about YouTube, because clearly I have no idea what I'm doing. I also really like a lot of their illustration classes, and the best thing about these classes is that they're so concise and high quality and to the point. They're not going to be these like hour-long courses that you have to do. They're extremely easy to consume if you don't have much time available. I mean, take a look at this MKBHD course as an example. Look at those times. These classes are perfect for you if you're busy, and I mean, who isn't? Coming in at just under $10 a month for an annual subscription, it's absolutely fantastic value, but Skillshare is also giving the first 1,000 people who click the link in the description below a free trial of Skillshare Premium so that you can check it out for yourselves and see what's on their platform. Huge thank you to Skillshare for sponsoring this video, and let's take a look at some particles. Okay, so here we have the cloned repository. Now it does build using CMake, so I'm just going to go ahead and quickly run CMake, making a little build directory, as per usual, to get some of these project files generated for Visual Studio. Great. So he did mention there was a, I guess in bin, yeah, there is this kind of 4 kilobyte executable, 3.62 kilobytes. That's pretty impressive. Yeah, demos are always really cool to look at, but let's just go ahead and build it ourselves so that we can examine the code as well. Okay, so let's expand this up. Source files. Okay, demo main, I guess, is probably a good place to start. Let's just build it and run it and see what we're looking at. Nope, got to make sure to set that as the startup project. It's got some music. Look at that, particles. I'm going to enjoy the full experience. So, okay, so controls he mentioned. Let me just bring them up because they are useful. Okay, so 1 to 9 is number of particles. Can't tell if that's like more particles or less particles because these look like they're so wide and condensed. But these look like they're just more spread out. Okay, that's cool. Shift and control is running speed. Ah, okay, I see. You can slow it down and you can speed it up. Left and right arrows changes the time direction. P is to pause and resume. And I is to restart. Or it just clears everything until I do that. Okay, cool. So that's the particle system. Let's take a look at how it's built. Okay, so the first thing that I want to point out quickly as I look through this code for the first time is this is a demo, right? I mean, this is clearly a demo. It's like a 4 kilobyte demo. It's supposed to be as short and to the point as possible. This is not some game engine that's going to just be written in a super easy to understand way probably, or using all the libraries. This is supposed to be really simple, and you can actually see the way that it starts up here as well. We're just using the Win32 API to create a window. Linking GLFW or SDL would massively increase the binary size, and that's not something that we need for a demo. Platform APIs like Windows clearly capable of providing us with a window, so why not just do that? So my point is that this is not good code to kind of read, I guess, to learn from if you're interested in making like actual applications or games, because it's a demo. By the way, the link to this code will be in the description. Every single one of these episodes does have the link in the description, so you can just, unless it was like sent to me in a zip file or something, this is on GitHub, so the link will be in the description below if you want to check it out, of course. And actually, one thing I forgot to mention was that I noticed this at the bottom as well. So there's a WebGL version. There's also an Android version, which is more advanced, which is really cool. So you can check this out on Android if you want. Okay, so step 1 is, let's see, we created GL window, I guess, and this is just all pretty much Win32 API code to create an OpenGL window, I guess. We load various OpenGL functions, which of course are all kind of done using WGL get proc address, because it's trying to be as small of a binary as possible. We're not trying to link any libraries. I guess this doesn't use any libraries at all. I'm sure if we went into like properties and we took a look at the linker, the only stuff that it links is all of this stuff. That's all available for you with Windows. It all ships with Windows. I also assume there aren't too many kind of advanced OpenGL functions. I would imagine, like, if I was running this demo, I'd probably try and keep it. I mean, he said OpenGL 3, I think, but I would try and keep it as low as possible. I assume he's going to need shaders to actually, you know, create the particles and stuff. But you know, you wouldn't try and use all the latest features because you don't need them. It's a demo. Then we instantiate this demo class. We run the constructor, which creates a whole bunch of stuff. Cool. All right. So screen width and height, sure, gets system metrics. So it's actually getting the physical like width and height of the display you're running on. Particle effect description, I guess. We have a bunch of const char pointers. So these are actually stored in the binary. So if we take a look at, let's see, build, I guess, debug, there's the executable. I'm going to open it in HXD, which is my favorite hex kind of binary editor, I guess. And then let's make this a little bit wider. Scroll down. Okay, so you can see that like the shader code, let me just kind of make this a little bit maybe easier to see. The shader code is literally just stored statically in the binary itself. Now, because the final output binary was 4K, I'm sure he's probably using some techniques to compress that, because text of course compresses extremely well, right? These are also GL draw, raise GL enable. Those are probably all the names of the functions he's retrieving. Using that kind of WGL get, you know, whatever it was. Here it is, WGL get proc address GL, and then he's concatenating the name of the function he wants. So that kind of, it's a macro, it expands, and it's in the binary now. But anyway, as I was saying, because the text compresses extremely well, he's probably further compressed that. So I imagine if we opened up the 4K, and I'm not like some kind of demo expert, by the way. I don't think I've ever made a demo in my life, at least not intentionally. Yeah, like this is the entire 4K file, right? I mean, there's no text here. So I imagine it's probably like compressed or magicked some way. I don't know. But that's basically where all of that code will end up. So these are all kind of just const char pointers. They don't need to be strings or anything like that. We don't need to like heap allocate anything or try and do that. We can just kind of store them in the static memory of our application, which is what's going on there. Okay, I've lost everything as usual. So let's see, demo. That's where we were. We were instantiating the demo and running through the constructor. Okay, so we have all of these kind of const char pointers to shaders, to shader code. Obviously, these aren't complete shader codes. They're just individual functions, I guess, which is interesting. Then we do effect.toShader, which sprintfs the Vertex Shader code with the Vertex Shader template and then the color font. Okay, all of these get like concatenated. Let's take a look at this. Well, not concatenated actually. This is the format, and then these are like all the, like, I guess percentage sign s kind of strings that get put in there. So this is really the key. So I don't know where this lives. Vertex Shader code. Let's just quickly, I don't know. I'll just search for it. Yeah, where does that get set? Oh, hang on, Vertex Shader template. Oh, sorry, that's the target. That's the format, my bad. So this is the buffer in which it's going to, put the resulting string into. This is the template, and this is, I guess, the actual, the format, right? So as if you were doing printf, and then you'd have your actual format string, and then these are like all the arguments for the format string. So this is the actual shader. Okay, and then, yeah, so you can see like there's like get position or like get emitter position, get size, get color, and then they just have percentage sign s, right? %s, which just means like take in the appropriate argument. It's a little bit dodgy, right? Because obviously the order of these matters so much. If you just mess them up, then your color function will be your size function and vice versa. So it's a little bit Dogecoin, but it's a demo. That's great, that's the best excuse. Write a demo and then be like, no, I had to do it this way, man. It keeps the binary size smaller. Best. Okay, so yeah, version 130, pretty old. Define particle ID as GL vertex ID. So we're probably, how are we actually rendering this? Maybe I'll start with there. So we do demo step, which, what does that do? Right, okay, so we're just doing some, I guess this is what's query performance counter as a Win32 API function that will actually retrieve like the current time for you. And this kind of sets it up as well. So this is like the current CPU time. So this is what we're using for time. It's like a 128-bit number, which is why quad part gets the kind of 32-bit out of it. So it's a long now. Maybe it's even a 64-bit because it is a long, right? How big is a large integer these days? Anyway, whatever. Get async key state so that's us just basically seeing if the key is pressed, resetting time to 0, which is what's supposed to reset the particle simulation. Rates, okay, right, 1 plus I. So this is actually how many particles there are. Yeah, so the lower the number, the less particles, right? So this is 2,000 particles, I assume, if we press the 1 key, and then if we press like the 3 key, it'll be 10,000 particles, right? So that's us just making sure that we do that we retrieve the current key. And then use it to actually, right, okay, and if it's not that key, we continue. So we basically run this 10 times to get the async key state of all of our, or not 10 times, 9 times, to get all of the key states of the 1 through 9 number keys. If it's not pressed, we just skip. If it is pressed, then we'll do all of this and we'll break, right? So this sets a bunch of uniforms and just figures out how many particles we actually want. Cool. Delta time, shift and control just increases speed or decreases speed. We know that. Left, right, set speed to be negative, right? So if speed is greater than 0, so it's just us reversing time, I guess, which is what runs it backwards. Paused. Okay, yeah. Anyway, this stuff is pretty straightforward. Render frame, this is what I want. So we clear the color buffer. We load identity, translate, rotate, uniform 1F time. Yeah, so we set the time into the shader as a uniform, and then GL draw arrays, GL points 0, and this is the count. Okay, so we're drawing everything as points. That's cool. I think actually, as I was skimming this, he did mention that this method is the only way I know to simulate particles on the GPU that can be implemented in unextended OpenGL ES 2.0. For example, it works with Mali 400 GPU, which is like an Android GPU, which has no support for Vertex textures, PBO, like pixel buffer objects, transform feedback, or compute shaders. Yeah, so we're dealing with like a pretty old kind of thing. But you know, that's not necessarily a bad thing, as I mentioned, for a demo, because I'm sure that this is going to be less verbose than like having to compile compute shaders and stuff like that, which is going to be pretty good. And it seems to perform pretty well. Okay, so we're drawing arrays. So what is the array that we're drawing? So we're probably creating it somewhere here. Time, rate, okay, these are all uniform locations. Oh, here we go, gen buffer is array buffer. So we're generating an array buffer. It's 4 bytes large. And no data is being set into there. I don't think do we actually need data if we're going to emit things. And then we enable point sprite. Okay, so point sprite and program point sprite. This is a blast from the past. So this is basically a way for you to be like, I'm rendering points, but I want to give them like a size. And program point size means that you can set that size from within the shader. So if we were to take a look at the shader, which we will in a minute, he's probably setting the size of the particles. And so we're basically just rendering these kind of sprites. And that's what the particles actually are. And this is the amount that we're rendering. So it's going to be the minimum of time and lifetime times the rate. That's just how many points we draw, and obviously the shader works out where they're supposed to be, you know, how big they are, what the color currently is, and all of that is figured out from the one uniform that is just the time. So we feed in this value into the shader, it runs all of the functions, all of the equations, and then we have a resulting, you know, position on the screen, a resulting a resulting color, a resulting size, all of that kind of stuff, just based off of this one variable that we run through all of those algorithms. So that's how all of this is working. And again, you know, we're rendering a lot of these. So here's a good example. So what's that even supposed to be? Gel size I, I'll be nice. Gel size I count equals that, and then I'll just print out, I'll be in the spirit of C or whatever, and we'll just do, what is this, unsigned long or something? It's an int. Wow, that's easy. We'll just do count here. So this is the amount of particles that we're rendering. Printf is undefined. Do I have to use like, oh, we don't have a console, do we? Oh, that's annoying. No. Okay, I'm going to destroy his binary by just including standard io.h. I don't think do we actually, yeah, we did create a console, right? So we've got, this is how many particles we have, right? So it's growing because we're spawning more and more particles. Did I just pause? We're spawning more and more particles. Obviously they're not dying, but at some point I think this is going to stabilize. Let's maybe make this a bit smaller, except now we can't resize it, great. Okay, so 50,000, right? And at that point, I guess those old ones are dying and stuff. But if I change this, now we have 8,000. If I change that, now we have, what is that, 1 million? Escape closes it, unfortunately. I was trying to release the mouse. But anyway, you get the point, right? So this is how many points we're telling OpenGL to draw, and then each one of those points is going to go through the Vertex Shader, and then eventually the Fragment Shader, right? So let's take a look at that shader quickly. Let's see. Oh, and the music stuff we haven't even taken. There's so much stuff to take a look at. These are always going to be kind of long, these videos, I think. Let me know what you guys think of this format at least, because I'm just having fun looking at this, to be honest. And I just think it's a pretty cool project that obviously you guys can check out for yourselves using the link below. So the shader, I think, is in shader.h. Yep. Okay, so this is the shader. We've got all the uniforms here, the viewport size. Let's see, just random number generation functions, rotation, I guess, getting a rotation matrix back from like some Euler angles. Get color, as I mentioned, is a product of that. So I guess we can take a look at one of those shaders as an example. So the color function, for example, right? So first of all, what does that take in? Let's go to shader.h. It takes in just time, right? So we have a t variable for like all of these functions, right? And then we're basically, I guess, generating a random number for the main color, which is obviously going to be at some point. Oh, we have birth time as well. So birth time, is that just something that gets set? Yeah, birth time is something that we create here. And I guess, yeah, get color and get time takes them in. And birth time, I guess, is going to be based on time and lifetime. Where does lifetime come from? Lifetime is a uniform that we pass in. Okay, cool. So we do keep track of some things, I guess. Like there's more than just time that goes into this. There's like, I guess, lifetime being just the lifetime, the age of like the particle. Or rather, should it be the total? Right, okay. The total lifetime, I guess. Lifetime. Let's take a look. So lifetime location, and we set that. Yeah, so we set that based on the number that we press, and also at the beginning, it's set to something. It's set to just 5. Okay, we have start color, which is just a function based on the birth time. By the way, these random number generators, just so that you guys are aware, this is not like calling a random number generator in like C++. This is all very deterministic. So if we look at the actual function that generates a random number, you can see what it basically does. So it is based off of a seed that you pass in, right? And then it will give you like a number that, you know, mathematically will be quite different from the seed that you obviously pass in. But if you pass in the same seed, you're going to get the exact same number again, right? Everything has to be deterministic. We don't want particles flashing around the screen or doing something weird like that, right? Everything needs to be recreated based off of a single value, and that single value in this case is that time variable. So that eventually comes into this. So if we go back to like shader.h, or sorry, this was in demo.cpp. So this is all based off of birth time. It's a random value, but it is also determined by birth time. If I pass in the same birth time, and this is just the y value of the seed, if I pass in the same birth time, I'm going to get the same random number out, right? So it's not really random. It's just, I guess, different, very different than what you pass in originally. And that's a lot of what like shader random numbers are. So if you see like random numbers being used in shaders, most likely, unless they're being passed in like by some uniform or whatever, usually they're deterministic, because just like if you wanted, you know, your shadow to kind of be, you know, smoothed out and scattered somewhat randomly, you wouldn't actually want it to be random, because then it would change every frame, and that would be like weird, it'd be flickering. So what you actually want is a way to make it seem random, but also to be stable and predictable, right? And that's what these functions are basically doing. And then we just return a mix of like a whole bunch of different colors based on a factor and, you know, whatever. I mean, this is the kind of stuff that you could probably sit down and play with for hours, just tweaking these algorithms. I love stuff like this, honestly, but I don't think there's much point in me trying to walk you through this code. It's all very like straightforward. It's all just maths, right? So you could definitely, if you're interested, take a look at this stuff and maybe even learn some stuff and try it out in your own code as well, or on Shader Toy, as I mentioned. Okay, so that's all the kind of rendering stuff. So the point is we just render all these points, and I'm assuming there's something in the Vertex Shader that actually, yeah, so we set the point size to be a particular value here. That's like the size of that sprite. And then we set the position to be somewhere on the screen. And so we are actually rendering geometry, kind of, right? This isn't like running on a quad, kind of like you might do if you were running this through a compute shader or just in a fragment shader. You can see that this is all kind of happening on the Vertex Shader. And then on the fragment shader, all we're really doing is getting that, I guess, coordinate, and then just drawing like the color, right? But the color is also based off of the factor, because I assume we want it to kind of fade out towards the edges, because this is the vec4 color, meaning it's also going to be affecting the alpha, right? So you'll probably get that fade off, and that's why you get the blending and stuff. I'm assuming he has blending enabled. Otherwise, nothing would work. Where would that be? Blend. I'll just search for blend. GL enabled, GL blend. Right. So if we didn't do this, it would look very different. Yeah, so this is actually a really good way to see what's happening. If you're a little bit confused, if you're looking at this and you're like a little bit confused, I'll just pause it by holding the title bar. If you're looking at this and you're a little bit confused as to what's going on, this is how it's being rendered, right? It's very, very obvious now. It's just, the music's still going, but whatever. Must be running on a different thread. Or something. That's annoying that I did that. But whatever. Anyway, you can see kind of what's going on here. It's just kind of drawing at that point. I wish I had the mouse cursor, but you can kind of see where it's drawing, hopefully new particles. And then if I change these, so this is me pressing like the 9 key now, you can see just how many points there actually are. But furthermore, you can see what the sprites kind of look like, right? And because they don't have blending, they don't really fade out. They just kind of remain as squares, and then you have that kind of black border, but the color still fades out. It kind of gets darker and darker towards black in like a circle kind of radius. And that's why, you know, the very corners are black, and you get this kind of nice radial pattern, I guess. And obviously if we were to enable blending back, everything would fade out very smoothly. And then the kind of blending effect, because that's the other thing, right? Well, let's take a look at this. You know, this isn't your typical blend function, right? It's not source alpha 1 minus source alpha, it's source alpha 1, right? So you get that kind of additive effect, which is why it's so bright, right? Because when stuff blends, it kind of gets added. Actually, blend func. I don't think the blend equation is being set anywhere, but that's kind of what you end up with. If you're confused how OpenGL blend functions and stuff like that work, I actually have an OpenGL video up there with like a PowerPoint presentation and everything going over some of the common blend functions and what they do. So check that out if you want some more information. All right, and last but not least, let's take a look at how the music works. Now, I'm not an audio programmer, even though I love audio. So let's take a look at this. Yeah, so it is running on a different thread. We have a music synth thread. WAV header. Okay, cool. So I guess this creates some kind of WAV file or something, because it's got like a header here with a particular sample rate, 44.1K, pretty standard. And then, yeah, we just have some mathematical functions, which at some point, I guess, get fed into some kind of synthesizer. And that's what actually creates this sound. So guitar note, we have some like certain amplitudes, I guess, that create actual, you know, notes and actual music. And then we pass in like, I guess, a frequency. So what tone, what pitch we want the note to be. And then what does that actually do? So I guess it adds it to like some kind of, yeah, destination buffer, right? And then we eventually, so this is the temp buffer, destination, and then we eventually, I guess, we play that. So guitar note, what is that called from destination? Vibraphone note, cool. All these different notes going on. That's all going into music synth, which is going into the thread function, right? That's calling, so that's the, okay, whatever. It goes into this destination, I guess. And then how do we actually play the music though? Where's that being fed into something? Ah, here we go. So this actually took me a little bit of time to find, but basically music init, right? This spins off another thread, which is this music synth function over here. That's running. That probably takes a little bit of time to run, right? Because it's actually going through and generating all this stuff. I don't know how long exactly it takes, but it's doing its thing on a different thread. Meanwhile, though, we create all of this stuff, store it in this kind of buffer that we, you know, have inside this music init function, and then we play this, right? So we pass in this buffer to SND play sound, which is like a Win32 sound player, right? And then it's just playing the buffer. And I guess that buffer obviously contains like the header for like a WAV file and everything. So it's as if it's really as if we like just, you know, read a WAV file from disk and then just passed it into this function, right? Except we've generated it all ourselves, including like the header information and stuff, and then obviously created the actual music using code, which is really cool. So if you're interested in some audio programming, this might be a little rough, but jump in and take a look at this kind of stuff, because yeah, it's really cool how we're able to generate music, and this isn't just some stupid sound, it's actually like a little bit of a song, which I think is pretty cool. All right, I think that's pretty much it. So we've covered like the music, we've covered the rendering. Yeah, I think it makes sense. Overall, this was a pretty cool project to look at. We haven't really looked at utilities, but this is like stuff like create windows and whatever. Yeah, I love looking at demos. I love looking at cool little projects like this. Let me know what you guys thought. If you enjoyed this, don't forget to hit the like button below as well, and check out the project for yourselves if you want to. If you want to send in some code or a project for me to look at, there'll be an email address in the description below that you can send your code to, chernoreview@gmail.com. Don't forget to check out Skillshare by using the link in the description below, and I will see you guys next time. Goodbye.